Hi, I'm Shuichi Murakami. Welcome to the Designing Landscape Form series. The theme of this episode is Let's Understand the Essence of Tree Form. In the previous episode, we learned how Garrett Ekbo created ambiguous forms by composing free rectangularity rooms with trees. The words he used to define space were not uniform surfaces. They were assemblies of branches and leaves. So what is the nature of tree form when trees act as elements that shape space? In this episode, we will explore the essence of tree form by focusing on the collective behavior of branches. When you think of the shape of a tree, what do you imagine? Maybe something like this. A straight trunk rising from the ground holding up a leafy canopy. This image is not wrong, but if that is where we stop, we miss what makes trees fundamentally different from uniform elements composing space. First, please look at this photograph. It was taken in winter looking up at a tree from below. This is not a dead tree. It is a deciduous tree, one that naturally loses its leaves during the cold season. The leafless period is an excellent opportunity to observe branches. At first glance, the countless branches may seem to be tangled in a very complex way. However, if you observe carefully, you will begin to notice a certain regularity. The branches become thinner as they extend toward the ends, and as they extend, the number of branches increases. Let's focus on a series of branches. Every time it divides, it becomes thinner. Now returning to the previous image, you can see that every branch becomes thinner from the base towards the ends, increasing in numbers as they spread. Eventually, you begin to see the branches as overlapping lines that diverge and multiply as they reach outward. Because branches are lines, there are always gaps. Through these gaps, the sky is visible. In other words, because a tree is an accumulation of lines, it becomes a transparent spatial element, and this way of seeing helps us understand how fundamentally different it is from the uniform spatial elements. Now let us deepen our understanding by looking at how this accumulation of lines is formed. That is, by focusing on the process that generates branch structure. Here is a simple diagram of the branching process. First, imagine a single branch. Buds appear at the tip and along its sides. A new branch comes out from each bud. Then, buds form again at the tips and along the sides of those branches. Each of those buds produces a new branch as well. Let's go through it once again from the beginning. Buds form a branch. Branches grow from the buds. Buds form on those branches, and new branches grow from the buds. If you like, try repeating this process several more times. You will see how it results in an accumulation of many lines. Note that this simplified diagram does not reflect the continued growth of the older branches, which is why it looks different from the photograph of the tree we saw earlier. If you increase the thickness and the length of the older branches at each stage, the diagram will begin to resemble that photograph. To deepen our understanding, let's look at some variations in the branching process. First, focus on the differences in how branches extend. In this simple diagram, the branch that grows from the apical bud and the branch that grows from the lateral bud are the same length at 1:1 ratio. Apical bud means bud at the tip of stem. Now what happens if that ratio changes? For example, imagine the branch from the apical bud grows twice as long as the one from the lateral bud at 2:1 ratio. As you see in the diagram on the right, the tree form becomes taller with less horizontal spread. If you like, try drawing several rounds of branching at a 2:1 ratio. The tree will stretch upward quickly while spreading only modestly to the sides. Next, imagine the opposite case. The branch from the lateral bud grows twice as long as the one from the apical bud, a 1:2 ratio. As shown in the diagram on the left, the tree will spread wide horizontally but grow less vertically. Try repeating branching with a 1:2 ratio. You will see the tree expanding sideways, creating a broad spreading form. In this way, differences in branch growth patterns can be understood as one of the factors that shape the overall form of a tree. Next, let's focus on the position of the buds. On the left, you see the branching diagram we looked at earlier. The lateral buds appear in an alternating pattern, first on the right, then on the left, and so on. On the right, the apical bud is in the same position, but the lateral buds appear opposite each other at the same height. Naturally, the difference in bud position results in a difference in the position of the branches that grow from them. The branching pattern on the left is called alternate branching, while the one on the right is called opposite branching. Although the effect is not as visually striking as differences in growth ratio, variation in bud position is also one factor that contributes to the differences in tree form. As you can see in this diagram, even with only two specific variables, the way branches grow and the position of buds, different types of tree forms can be generated. In reality, however, the situation is much more complex. Growth patterns, branching angles, the number and position of buds, all of these vary depending on the species, the individual trees, and even each branch. In addition, external factors such as physical pressure, wind, or damage influence growth. Through the interaction of countless variables, the simple repetition of branching becomes increasingly complex, resulting in the magnificent branching structures we see in real trees. Here is today's summary. A tree is an assemblage of lines, the result of countless repetition of branching. Gaps inevitably occur between the branches. Even when leaves appear, those gaps never completely disappear. Because of this, a tree becomes a permeable structure, and as a spatial element, it possesses the quality of transparency. This transparency is the very opposite of uniformity. It is a complex pattern woven over time through the simultaneous and continuous process of branching. In the next episode, we will explore fundamental methods for composing space with trees, drawing inspiration from the work of Dan Kiley, one of the foremost landscape architects of the 20th century. Some of you may have been deeply impressed by magnificent architecture, where a beautifully ordered array of columns supports a graceful canopy above. In a similar way, through the natural process of branching, trees can also create spatial compositions of columns and canopies within the landscape. See you in the next episode.